Okay, in this problem, they're asking us to use cylindrical shells to define the volume of a solid obtained by rotating the region bounded by y equals x squared, y equals 0, and x equals 4. So I think I shaded that area in. That green area is the region that we're talking about. So do you remember what cylindrical shells are? I think of it as rings, the rings around a tree stump. You know, when you cut a tree down and you look and see the rings that are in the tree stump going around and around and getting bigger and bigger as you work out. That's the kind of thing we're looking at here. So we're going to rotate this thing about the y-axis. So it's going to come out like this. It's going to swing around that y-axis. And kind of think of it as like a semi-hollowed out tree stump. I guess you could think of it that way. And there's going to be shells. There's going to be rings around the tree that come out from the middle, right? And we found, if you go back and do your reading, that they came up with this formula, a way to solve for the volume by using integration. So what do we have to integrate? 2 pi times the shell radius. So think of it, there's a shell here, 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 here. There's a bunch of shells. Their width is dx. Their radius is the distance. I always remember the shell radius is the distance from the axis of revolution. So the radius of the shell, which makes sense, is the distance from the y-axis. So this is a particular shell at this point, okay? And what's the height of this shell? From here to here, right? And the width of the shell is dx. Okay, and we're going to integrate from x equals what? 0 to 4. Okay, here's a little note that I also think about. If you're rotating around the y-axis, get your integral in terms of x. If you're rotating around the x-axis, get your integral in terms of y. So it's like the opposite, right? So I write that down and it helps me. So let's see. So let's figure out what the volume is using integration. So I'm going to use the formula. So what is it? We're talking about x. So our x for this region goes from 0 to 4. 2 pi is there. The shell radius is the distance from the axis of revolution. Well, that's just some particular x value. It's some particular x value, so we're just going to call that x. Okay, and what's the height of this shell? It's right here. And what's the height? It's x squared. Right? So let's combine this, make it a little prettier, put the 2 pi in front, 0 to 4. It's just x cubed, right? Right, so we have to take the antiderivative of x cubed. So isn't that 1/4 x to the 4, between 0 and 4? Is that right? So let's see. The 2 cancels out with a 4, so you end up with just pi over 2 x to the 4th between 4 and 0. So what's that equal? That's equal to pi times 4 to the 4th over 2 minus 0, right? So I think they want it as a decimal, so I carried it out. I don't know how many decimal points they want, but that's what I carried it out to. Okay, so the key here is get the formula for the volume using cylindrical shells. Realize that the radius is the distance from the axis of revolution. In this case, it's just x. The height is basically what that function was, which was x squared. And then just do the integration. So I hope that helps. This is important to remember too. Okay? Great. Good luck.